What's up, Algebra Bros? In this video, I'm going to show you how to find the intercepts of a circle whose standard form equation I demonstrated how to get in a previous video. The standard form equation that we got towards the end of that problem was x minus 3 quantity squared plus y plus 5 quantity squared equals 16. So I'm going to help us figure out the location of the intercepts of this circle. Let's go ahead and dive right into it. First type of intercepts are x-intercepts. Now, as a reminder, to find x-intercepts algebraically, what we do is we set y equal to 0. And so that means in this standard form equation, we'll replace the variable y with the number 0 and then see what happens afterwards. So this is going to be x minus 3 quantity squared. Now when y is replaced with 0, the inside expression of the second set of parentheses becomes the number 5. That gets squared, equaling 16. What you want to do next is square the 5 to get x minus 3 quantity squared plus 25 equals 16. Next, you want to isolate the expression x minus 3 quantity squared, and we can do that via subtraction by 25 to each side. This results in x minus 3 all by itself, x minus 3 squared all by itself on the left, and on the right, we're going to have negative 9. We'll now proceed to get rid of the power of 2 here, and we can do that by square rooting each side. And when you square root the right-hand side, be sure to include plus or minus. You end up getting x minus 3 on the left, and then plus or minus 3i. And here's where we can actually stop with our solution. And the reason for that is because these two numbers right here are non-real. They're complex numbers. And we're not able to plot points with complex coordinates, those that include the imaginary unit I, in the coordinate plane, because the coordinate plane is based on the x-axis and y-axis being real number lines. So what do we conclude based on this information? Well, the fact that we're getting non-real numbers when we go to solve this equation means that there are no x-intercepts. And if we look back at the graph from the last video, that should make sense because our circle has no intersection with the x-axis whatsoever when we plot it in the coordinate plane. So this is more or less algebraic verification of that fact. Let's move on to y-intercepts. To find y-intercepts, the protocol is to set x equal to 0. So this time in the equation, we'll replace x with 0 and then solve the resulting equation. So that's going to leave negative 3 inside the first set of parentheses squared plus quantity y plus 5 squared equals 16. Now be careful here, negative 3 squared is positive 9. And much like in the last part, the x-intercept work, we're going to want to isolate the y plus 5 quantity squared, and we can do that via subtraction by 9 to each side of the equation. We're going to get y plus 5 quantity squared equals 7. Next, we'll get rid of the power of 2 by square rooting each side. Again, plus or minus on the right. Okay, these cancel. You have y plus 5 equaling plus or minus the square root of 7. Now here, we don't have to worry about there being no y-intercepts. In fact, the fact that we're square rooting a positive number instead of a negative number indicates that we actually have y-intercepts. We're not quite ready to state what they are until we move this positive 5 from the left over to the right hand side. And here's how you want to write this. Y equals negative 5 plus or minus the square root of 7. So this graph should have two y-intercepts. The exact value of them are as follows. Y equals negative 5 plus radical 7, and y equals negative 5 minus radical 7. As ordered pairs, x will be 0, just based on our substitution, comma negative 5 plus radical 7, and 0, comma negative 5 minus radical 7. And so these would be the exact location of the two y-intercepts. Referencing our graph from the last video, it appears as though there are in fact two y-intercepts. That point right there is most likely our 0, comma negative 5 plus radical 7 intercept. And then this point right here is most likely our 0, comma negative 5 minus radical 7 y-intercept. And I'm going to leave it up to you guys to punch these two y values into the graphing calculator to get an approximation of them, and see if the decimal approximation the graphing calculator gives you lines up, with where these y-intercepts are approximately at in our diagram. I'm sure the results will be awesome to see. Alright, and that's it for this video. Of course, if you have any questions, feel free to let me know. Otherwise, I appreciate you watching, and stay mathy.